Okay, this is the video solution for the homework in Lab 4 afternoon session. And what we are dealing with here is a shrink-fitted part, so aluminum shrink-fitted in brass. The diameter of this aluminum piece is a little bit bigger than the other one, and you are asked to use the most appropriate element, okay? And obviously in this case going to be solid elements. That's what we're going to be using, and also use as many planes of symmetry as necessary. Now when you look at this problem, if you look at the vertical cut here, a vertical cut along, for example, that top hole, and then you take a 45-degree sector, notice that that particular unit is repeated 8 times around the circle. Okay, that being the case, the plane of symmetry that we're going to take is, of course, halfway, definitely halfway through the part, 0.5 inch through the thickness, and then we take a 45-degree sector here, which is cut like that. That's the most appropriate, the smallest unit for symmetry taken into account. Okay, so let's go ahead and do that. I'm going to start doing the inside the inside part first. So now I just want to remind you that when you do shrink fit problems, you have two choices. You can make the size without the size of this inner disk without taking 0.002 into account, and then declare the basically the overlap being half of it, 0.001, or you can actually make the cut, make the part with the radius, for example, 3.001, and then again declare the overlap to be 0.001. The results are going to be very close. So what I'm going to do is I'm going to use the nominal diameter of 3, a nominal radius of 3 for the inner part, okay? Okay, so let's go ahead and do that. We go here. First of all, let's start with the product file. Start, oops, right here. Start product. Okay, good. And immediately I'm going to save this thing. File, save management, save as, my desktop, a new folder, and the new folder is going to be Shrinkfit. Lab 4. How about afternoon? Okay. Okay. All right. Now we're going to insert our first part, insert a new part in there, and I'm going to call it properties aluminum. Let me call this thing inside piece. And by the way, it's made of aluminum. So this is the name that I'm going to give it. And I'm going to copy this. Copy, because this is the instance name. The part name is actually right here. Paste. Say OK. Notice that this is changed. Now I'm going to make the part. So expand the tree here. Double click on this branch so that you go in the part design, which is right there. You can see that. On that vertical plane, I will sketch that circle, 45-degree sector. So something like that. We clean it up here. So yeah, actually, let me do the following. Let me do another one. Okay, so clean it up from there to there. This top one, if I'm doing the top one, I want to take the circle into account, no problem. And then another one from here to here. And we're going to do a quick trim, first of all. So the quick trim, the eraser right there, gets rid of this, and that, and that, and that. Might as well do the circle here. Let me clean it up. Oh, this one is the outside. This is the inside one, right? Yeah, that's the inside one. Does not have a circle up there. So let's dimension these. So this is going to be that radius is going to be 3. Remember, I do not use 3.001. I use 3, the nominal value. And this one is, I believe, radius is 1. The whole inside hole radius 1. Okay. So what I'm drawing here for you is this yellow piece, basically. Okay. Oh, sorry, this radius should be 0.5. That's what it is. It's diameter 1. 0.5. Okay, that's what you got right there. All right, so, oh, this angle, 45 degrees. Where is that dimension? Between this line and that line. 45. Exit. We're gonna pad it by 0.5, half the height of that disc, because we're assuming these are discs which are shrink fitted inside of each other. 0.5. Good. And we're going to apply material to this, which is aluminum. So let me see. Here's material, apply material. On this part, not on the product, on this part, aluminum, and we say OK. Good. All right. So if I go all the way to the top and click on this floppy, it's going to save this part in that folder. Good. Why don't I change the color of this also? So let me see now. Right-click, Properties, Graphics tab. I'm going to change that thing to yellow so that it looks just like that. Actually, it looks like you can do it from here, so close that. Do it from there. Right-click, Properties. On the graphics, now you can change the color to green. Sorry, yellow. That's what I meant. Okay, good. Now we're going to insert a new part in there. Always say no. Try reading it once, at least you know what it says. I'm going to change the name of this. Right-click, Properties. Since I already copied that on the product, already copied the previous one, paste, except that I've fixed this outside piece, and it is steel. Steel. Say OK. Oops, I forgot to do this was the instance name, so let me try it again. Right-click, Properties. Yep. Now let me copy this. Right-click, Copy, and scroll down. And there is the actual part number or part name. Paste. Say OK. Good. Now to make it, I just double-click on that. Now there are different ways of doing this thing. Here's the way I'm going to do that. On that, for example, again, on the XY plane right here, please notice that there are many ways of doing this thing. I'm going to do this. Okay, very good. And I'm going to project this arc. Yeah, project that. And yeah, that's good. Exit, not exit. So this is projected. If I hide this thing, you can see what happened. There we are, and do the rest of it. Now, the diameter, the radius of that outside gray piece is 5. So let me go and why don't I do this? Draw a line from here. And we're going to clean this up, not to worry. Okay, I think that's coincident. You can see that. I am pretty sure these are coincidence. If not, we're going to fix it. Okay. Uh, for example, you can check it. This control that. Are they coincident? Yeah, they're already coincident. We can see this. All right, good. And the circle, an arc basically. Okay, the center is here. It starts there, goes there. All right. And this radius is 5. Radius is 5. Okay. And I'm doing the gray piece here. Okay, so let's complete this line from there to there. Okay. Let's do a bit of a cleanup here. I use the quick trim to get rid of this. Okay. And now I have to, notice that because I projected, I don't have to make this angle 45 degrees because it's already 45, but that's up to you. Now this one, there's a circle here. For example, there's a circle like that, half a circle, a quarter circle, something like this. And we're going to clean it up. I wanted to do a better job, no problem. From there, control that line and make it coincident so that it wraps it up. Okay, good. Now the radius of this guy is 0.25. Okay, so let's put a radius here. 0.25. Okay, and the distance from that point, the center of this, to the center of the assembly is 4. Okay, so that is this dimension. See that this dimension right there? So this dimension from this point to that point should be 4. Okay, and do a quick trim to clean this up. Basically, we got to get rid of this. Good. Exit. All right. Now, if you want to see the other piece which is which is hidden, it's right there. Let me bring it in the front so you can see it. We're going to pad this thing up by 0.25, by 0.5. Now, once again, I want to remind you that I could have drawn this yellow piece with that distance being 3.001 instead of 3, but I used the nominal one. The results are going to be very close to each other. Okay, good. Let's apply the material to this thing. Apply properties on that piece. That's steel. We say okay. Yep, that's pretty much it. And we go all the way to the top, and we save this. Floppy, click on the floppy, it's going to save this new part. We haven't made any changes to the other one, so it's going to do it anyway. So now we're done. So we're going to go to generative structure analysis or analysis and simulation. generative structure analysis. We don't want to do any fancy stuff. If you, for example, you know how to refine the mesh in area that you may want. Let me see actually what the problem's asking. Yeah, it doesn't say anything about defining around the hole, but if it did, you could. This is, by the way, the break, because this was from a previous test. This is how the points were broken down, and read this thing carefully. It says if it doesn't run, it's automatically discounted by whatever. Now, you want to look at the mesh, right click, mesh visualization. Okay. Now, you know what? What if we wanted to make a fine mesh here? So let's do that. Deactivate this. Okay, so let me hide this. You know how to refine the mesh. Model manager, where the traffic light is, click on local mesh size. You select it says, well, which one of these you want to define? Obviously, it's the mesh right now. It's the mesh for the aluminum is that I want to define. It says, okay, where? It's right there. And this is the size that it takes, which is fine for me. And I'm going to do the same thing on the other side. Okay, I want to do the same thing on the other side. So let's do another one. This time it's that mesh that I want to define. It said, well, where is it? Well, the part is in hiding, so let's go get it. That side. And this size is fine for me. Okay, let's bring this thing in the front so you can see it. Okay, so activate the mesh, right click, mesh visualization. You see that at that interface, you have find your mesh. I didn't ask you to do it, but you should be able to do it on test fast. Right there, you can see that. So deactivate. Good. Now, let's see now. We're going to make these surface sliders because this is a plane of symmetry. That is a plane of symmetry. I can do them all in the same place. This is in plane of symmetry. That is a plane of symmetry. And that is a plane of symmetry. And the bottom for both of them. Because remember, we cut the disk through half the height. Okay. So these are all the things that I want. I think we did all of them. Yeah. Cancel that. We have our surface slider here. Right there. Now, to create the pressure fit, you have to create an analysis connection. Like this analysis connection between these two mating surfaces. So right-click this. First component is going to be that face. Second component is going to be the one that I hit, which I can either get it back or just go back in the hidden space and select it. Right. Let's go. Let me bring this thing in front. Okay. So we created our connection. It is right here. You can give it a name. You could have given it a name, or you can do it now. We don't want it. So go to the connection properties. You see this? You see that? First, we created the analysis supports, general analysis connection. Now we have to see what kind. These are face-to-face connections. So expand this thing. Look for here something that looks like a pressure fit. It's right here. Pressure fitting. Click on it. It says, okay, where is that connection? It's right there. And what is the value? It is how much they have interfered with each other. It's 0.01, right? So this thing was the diametral size was 0.002. So they have actually should be penetrating each other by 0.001. So let's see if we got it. Yep, it just happened to be the right value. Because last time I did this thing, maybe a year ago, it had the same value. Now, let's change the analysis first of all. File, save management. There's the analysis, save as. In that folder, is that the right folder? Yep, shrink fit, lab 4, afternoon, right there. We say OK. and we're going to run it. Okay. Okay, after it finishes, you can actually look at the deformation, and I'm going to change the rendering here to the edges. You can see that there's all kind of junk here in the middle, and the reason this is happening is because this steel piece is going to be pushed out, the aluminum is going to be pushed in. So you don't want to display these contact elements. Just double click on this thing on the selection. Just use the first one and the second one. Don't show any contact elements, okay, right there. Now, if you see this gap here, that's because of the scale. Go put it on the real scale. So real scale is 1. Oops, 1. Say okay. Notice that it doesn't show you any gap. Okay, so this is actually what happens. If you look at the deflection, double click, and once again change the. Just show me the 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 actual elements, not all the artificial ones that were created because we have to do pressure fitting and things like that. And then double click, actually just change the rendering to material shading and change the okay, maybe I should ask for the average ISO, yeah, and change the scale to 1 so that you don't see that artificial gap there, which is artifact basically. And finally, you can look at the von Mises stress. It's the same story. Now, just double click on, just click on the scale, make it 1, and you're going to see this. Okay, and that kind of takes care of what we did. What I would like to do is go to my geometry. But by the way, look, the maximum stress 9.09, okay, which is at the interface basically. If we go here to the which aluminum, it was the aluminum part that I used three radius being 3 inches. So let me go there. Let me go to that sketch and change that to 3.001. In other words, take that initial penetration, exit, and let's run it. Let's go here, run it, and now look at the this von Mises stress. Right click, activate. You see, it does change a little bit, but not substantially. I mean, uh, so that initial penetration, whether I include it or not, it did not affect the stress distribution significantly. So it's up to you. All right, that takes care of